So cholesterol is that steroid-based molecule that we looked at earlier, and now I want to talk a little bit more about what its role is. And so cholesterol is actually a major component of cell membranes. And I know that we often think of cholesterol as being a bad thing, but it is actually critical and an important structure in cell membranes. So what does it do? Well, its role basically is what I would call a fluidity buffer. Fluidity buffer. Not a pH buffer, but fluidity. And what I mean by that is that it keeps the membrane fluid, as in, not seizing up, not getting too viscous at low temps, but also keeps it a bit more rigid at high temps. So in other words, it prevents the cell membrane from really changing its fluidity as temperatures go up and down. And so for that reason, I often refer to it as a fluidity buffer. So remember, I said that cholesterol is amphipathic, meaning that it has this very nonpolar region here, and it kind of sits in the membrane just like this, where it can have London forces interactions with those nonpolar tails. So it's got all that nonpolar side here, but then also it has that hydroxyl group, which is polar and can hydrogen bond with, say, polar groups on the head of these lipids, or even perhaps with water out in the cytoplasm. So that's that amphipathic nature that we expect for a membrane lipid, and cholesterol definitely does that. And so you may have heard of cholesterol being bad or good or whatever, and there's only one cholesterol molecule, and we're looking at it. Cholesterol is good or bad depending on where it is, not what the molecular structure is. There's only one type of cholesterol. And to understand that, we have to understand how cholesterol and lipids are transported around the body. There are two different types, roughly speaking, of these lipoproteins that carry and transfer cholesterol and other lipids around the body. Now, the low-density lipoproteins are often referred to as the bad cholesterol, and the HDLs, the high-density lipoproteins, are often referred to as the good cholesterol. And it's not that the molecule cholesterol is any different in these two things. It's the same cholesterol molecule. It's just that these LDLs and HDLs have different roles in the body. And to explain that, I want to show a little kind of a representation of the body here, very simply speaking, where we have the liver in one hand, or on the left-hand side here, and then we have the blood, which of course circulates throughout the body, and we have the tissues. So this could be your heart, it could be your skin, it could be organs, whatever. Point being that liver is pretty good at making things and recycling things, and the liver is kind of the master of a lot of those different types of things. And so in the liver, then, there's some amount of cholesterol that is produced, and we also have cholesterol from our diet that we take in, so it's a balancing act between those. And what happens is, if the liver is making cholesterol and that needs to go out into the tissues to, again, embed into the cell membranes to make sure the cell membranes are healthy, then that cholesterol leaves the liver and is bound inside the things called LDLs, which are quite large. And then it's going to deliver that to the tissues, whatever the tissue happens to be, whatever heart or organs, so that the cholesterol can be embedded in the membrane as it's needed there. So think of LDLs as FedEx, right, or UPS or Amazon, in that it's delivering the cholesterol to the neighborhood, in other words. And then if there's too much cholesterol, or an excess of cholesterol, then it needs to be removed from the tissues, right? And those are traveling in what we would call HDLs, which are a little bit smaller structures. So think of this one as the garbage truck, or we could say the recycle truck. Right after you have used your FedEx products, the cardboard ends up in the recycle. You got to get rid of it, right? And so then that goes back to the liver to be recycled or degraded or whatever. And so what ends up happening is we have the LDL, which is bringing cholesterol out to the tissue so it can be put into the cell membranes. And if there's too much cholesterol building up somewhere, the HDL is serving to transport it back to the liver to be degraded. And so if there's a lot of the LDL present, that's a sign that there's a lot of cholesterol going out to the tissues. And if there's not much HDL or too little HDL, then that's not being picked up. And so you can just imagine you've got all these deliveries, all this cardboard or cholesterol stacking up in the tissues and not being recycled. And so the analogy there then is that cholesterol would do that. Cholesterol would build up inappropriately. And if there's too much out circulating, it'll start forming plaques and cause atherosclerosis, where your arteries harden and start having heart disease and those sorts of things. So that's why LDL is called the bad cholesterol, because if there's an excess amount of it, it causes the buildup of cholesterol in the arteries. Whereas HDL, if there's a lot of that, it actually is a signal that cholesterol is being taken away from the tissues and brought back to the liver. And of course, this is dependent on diet. It's dependent on your genetics as well. But just know there is only one cholesterol molecule. When we're talking about good or bad cholesterol, we're talking about how it's being transported.